The Christian belief that God created the earth inspired more ideas relating to the universe, including Aristotle's proposal that the earth is a spherical planet centered in the universe, as well as Galileo's support of the sun-centered model of the solar system. Now we have the Big Bang Theory. About 13.8 billion years ago, space and time were created by an unimaginably gigantic explosion, the Big Bang. However, before this occurred, the Big Bang Theory predicts that all matter would have been at a point of infinite density, which is called a singularity. When the singularity in a few millionths of a second expanded from being unimaginably tiny, dense, and hot in a process called inflation, the universe was created and then became cooler and less dense, enabling the formation of matter. The universe is still expanding today, although at a much slower rate. Subatomic particles, energy, and fundamental forces, including the strong and weak nuclear forces, electromagnetism, and gravity, are then immediately formed, which combine to produce protons and neutrons. The combination of protons and neutrons then create the basic elements hydrogen and helium. Cosmic microwave background is a type of radiation that filled the universe after the Big Bang and could be studied to learn the composition of the universe. Scientists predicted its existence in 1948 based on the idea that if the universe was initially extremely hot, we should be able to detect traces of heat through microwaves. It was then discovered in 1964 by Arno Penzias and Robert Wilson when they accidentally identified radio waves emitted from the center of the Milky Way galaxy using the Holmdel-Horn antenna. This discovery sparked the fall of the 1940 steady-state theory, which states that the universe is infinite as it is expanding but doesn't change its look over time. Thus, new matter must be formed for the density to remain constant. Another piece of evidence for the Big Bang is Hubble's law on redshift. When astronomer Edwin Hubble discovered that the universe is expanding in 1929, he discovered that most other galaxies must be moving away from us. He then used redshift to prove that galaxies move away from us at speeds proportional to their distance. In other words, the further away a star or galaxy, the more of its light is redshifted and therefore the faster it moves. This is due to when light is moving away from us, its wavelength becomes longer, so the light is shifted into the infrared or red end of the spectrum. Stars and galaxies formed roughly a billion years after the Big Bang, when the universe was filled with hydrogen and helium. Due to the density of some areas, the universe expanded slowly, allowing the concentration of hydrogen and helium in small protogalactic clouds, which are clouds of gas forming a galaxy have sufficient mass to eventually form a galaxy. Gravity caused the gas and dust in the clouds to collapse and stars formed when tremendous amounts of energy were released as a result of nuclear reactions. Eventually, the stars were burnt out to become compact star clusters, commonly known as globular clusters, while gravity continued to collapse the protogalactic clouds, which turned into rotating disks. This attracted more dust and gas, and galactic disks were formed, which is where the majority of a galaxy's mass lies. A galaxy is produced when new stars are created in these disks. The formation of stars has had a major effect on the universe due to the nuclear reactions inside the stars that form heavy elements creating atoms and molecules. The Sun is a yellow dwarf star created about 4.5 billion years ago when our solar system was formed from a supernova or stellar explosion. Held together by gravity, it is a sphere of ionized gas and creates intense heat and pressure in its core, an reaction called nuclear fusion. However, solar radiation is reaching the Earth due to the luminosity of the Sun increasing throughout the next 4 years. This will cause the level of carbon dioxide in the atmosphere to decrease, lower than the required level for photosynthesis to occur. Therefore, not only plants will become extinct, but the whole food chain would be disrupted. In 1.1 billion years, the plate tectonics and the carbon cycle may be non-existent due to the evaporation of oceans. Although the Sun is currently stable, it is halfway through its full life cycle and still expanding. Scientists predict that it will remain stable until another 5 million years, when the Sun would have consumed all of its hydrogen in its core. At this time, the Earth would have been absorbed by the Sun due to its expansion into a red giant star. This occurs when gravity makes the core of the Sun smaller and hotter, resulting in its outer layers expanding, which is predicted to occur in 6.2 billion years. Once a red giant star burns out, it will collapse into a planetary nebula, a cloud of gas and dust. The outer layers of the gas are discharged and the star's core contracts due to gravity into a white dwarf. One of the most prominent predictions for the future of the universe is that it will become simpler. This is due to the effect of dark energy, a hypothetical form of energy that produces a force that opposes gravity, which causes the expansion of the universe to accelerate. Galaxies become more isolated, leading to all the stars burning out and being pulled into black holes. Apparently, in 100 trillion years, the last star would flicker out, black holes will evaporate into nothing, and the universe will come to an end. Other predictions include the Big Crunch and the Big Rip. The Big Crunch is predicted to occur in approximately 100 billion years and is the reverse of the Big Bang. It is when the universe lacks dark energy, making gravity eventually stop the expansion of the universe and instead start to contract until all the matter collapses to a final singularity. The Big Rip, predicted to occur in about 35 to 50 billion years, is where dark energy would increasingly accelerate the expansion of the universe. Eventually, the fundamental forces would be overwhelmed, resulting in galaxies, stars, and atoms being torn apart and the universe ending in a gravitational singularity. From here, would another Big Bang occur to form another universe? Join me in 100 billion years to find out.